Hi guys, so during this video I'm just going to go through last night's exam question. Exam question included kind of revision of what we've been doing during this topic, and it also looked at a Hess's law question. So I'm kind of going to jump back and forth between these two. So the first question, and all of the answers, sorry, are just on the next slide. The first question is asked, okay, we have to state isomers, draw structures for 3 of the isomers of C4H. Our next question in this was asking me to name 2 other processes carried out in oil refineries to modify hydrocarbon structures. So those 2 other processes would be reforming and they would be isomerization. Now remember, reforming is the exact same as dehydrocyclization. To name hydrocarbons, to define them, and to define structural isomers. So hydrocarbons are compounds of carbon and hydrogen only, and you can see carbon and hydrogen are in bold there, so you really needed to have them. And a structural isomer is a compound with the same molecular formula but different structural formula, both of those for 4 marks. Part B, you had to give a use for the kerosene fraction obtained when crude oil is fractionated. You had loads of examples here, so you could have said domestic heating, paraffin oil, bus fuel, solvent, it's a lubricant, anything like that. But you also had to explain why some of the kerosene produced in oil refining is subject to catalytic cracking. Okay, now the reason catalytic cracking or kerosene might undergo catalytic cracking is that there's actually greater demands for shorter chains. Why? Because those shorter chains have increased octane numbers. Okay, so remember, we wanted to increase our octane numbers because that means it's better fuel. Okay, it resists knocking even better. Next question was asking me to a straight chain molecule of C13H28 occurs in the kerosene fraction upon cracking C13H28, a C2H4 C4H molecule, and another molecule. We had to identify this and draw the structures for the 3 isomers. So with regards identifying the final overall, and we would look at the 2. So we may, in total, we have C13H28. In the middle, we have made C2H4 and C4H8. So in total, we have used up C6, I added the 4 and the 2, and we've used up H12, I've added the 8 and the 4. So the easiest thing for me to do now is to take my total values of carbons and hydrogens away from the total. So I'd have C13 take away C6, and I'd have H28 take away H12. So I'm left with C7 and I'm left with H16. Now that's heptane. All single bonds, hept for 7 carbons. So I've literally added together and then I've taken them away. Heptane number, it's one of our reference hydrocarbons, we should know heptane. Heptane is an example of a poor fuel and it has an octane number of 0. The other reference hydrocarbon that we need to remember is our 2,2,4 trimethylpentane. Okay, you are then asked to draw your 8. Okay, so we have to draw C4H8. So the easy one first. 1, 2, 3, 4. Fill in your hydrogens. Sorry, I moved this over. So I didn't change color on purpose there, guys. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So that means I'm going to need to have a double bond here to make up my valency. Another way we could draw C4H8 is take into account that we have a double bond here and that we have branches coming off it. Oh, sorry, that should be CH3. CH3 and then 2 hydrogens here. So you're looking at the exact same ingredients, just putting them together a different way. Another way you could draw C4H8 is you could put both branches onto one chain. So you could have C with your CH 3 and CH3, and then our double bond C with our final 2 hydrogens here. And our final way that we could is we could kind of turn it into a box that we would have CH2, 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 and a CH2, but all of those being linked together. To complete the last part of the question, which is the Hess's law part. My question reads, the combustion of one of the C4H8 isomers is described by the following balanced equation. The heats of formation of water, carbon dioxide are those two figures respectively. We want to calculate the heat of formation of C4H8. Now, with this, you have to use the 3 equations whose numbers you've been given. So I've been given this guy, the first one up here. I've been given water and I've been given carbon dioxide. I have not been given the numbers for the formation of C4H8, so that's what I'm going to want. And in this instance, as opposed to the ones we did on our live classes, it's it normally is the equation that they give to us that we have to figure out. This time around, we have to build the equation that they want us to figure out. So C4H8 is our final product here. So we're going to have 4C plus 4H2 to give me C4H8. So that is what I want. That's our end game. And we've been given 3 pieces of information to help us with that. The first one is our C4H8 plus 6O2 to give me 4CO2 plus 4H2O. And they've told us in a question that the value for that is minus 2,710. Okay, the next equation that they've given us is water, or the value that they've given us, sorry. And the value for water is minus 286, so we have to put the equation together. So that's H2 plus half O2 to give me H2O. And our final one, you probably noticed in these questions can take up a bit of space. Our final one is carbon dioxide, CO2. So to make carbon dioxide, we get C plus O2 to give me CO2, and my delta H value there is minus 394. And what we need to do now is we need to look at equation A, B, and C and see what we need to do to them to make our final equation. So with the first one, I can see that they have C4H8, and that's what we need. So I'm going to reverse this. I want it to be on the right side, so I'm going to reverse it. So as I reverse it, I get 4H2O plus 4CO2 to give me C4H8 plus 6O2. And as I reverse that, I need to reverse the sign as well. So I get a positive 2,710. My next question, or my next thing that I need to deal with is equation B. And we can see in equation B, the only thing that they have there that we want is the hydrogen this time. So this time around, I'm going to multiply this one by 4. So I'm left with 4H2 plus a half by O2 is going to give me 2O2 to give me 4H2O. We multiply our minus 286 by 4 and we get 1,144. And our last one in this that we need to manipulate, guys, is our carbon dioxide. Now, if I go back to what I want, I hope you can see that up here in this equation, I need 4 carbons. And the only place to get that from is from equation C. So I'm going to multiply everything in equation C by 4. So that leaves me with 4C plus 4O2 to give me 4CO2, and like that I multiply my delta H by 4, so my minus 394 by 4, and that gives me minus 1576. Now if we have done this right, by adding up what's on the left and right hand side and cancelling excess things out, we should be left with the equation that we want. So on the left hand side I have 4H2O, I also have 4H2O on the right hand side. I have 4CO2 on the left hand side, I also have 4 CO2 on the right hand side. I have 2 plus 4, which is 6 O2 on the left hand side, and I have 6 O2 on the right hand side. So if I write down now what I am left with, so you can see that we are left with in total 4H2 plus 4C to give me C4H8. And if I scroll up to my original question, 4C plus 4H2 to give me C4H8, that's exactly what I wanted. Right, so the final thing for us to do then is to add together all of these answers, or all of these numbers. So our minus 2710, our minus 114, and our minus 1576. And when I add those three figures together, guys, I get a really small answer. I get an answer of minus 10 kilojoules per mole. Okay, I hope that makes sense. If you have any questions, just send it on to me. I hope you're all well, and I'll be going through more of these next week.